Hi, this is Google Kickstart question, Touchbar Typing, and this is the third question from round D. In this question, we need to return the minimal time needed to type the string S on the keyboard K. So, in this example, we have this string, which has four numbers, 2, 1, 4, 1, and we need to print this string using this keyboard that has 8 keys, and the index of these keys are from 0 to 7. And to do that, for example, we need to start with this number 2, and we press this key 2, and then we need to print 1, so we move from 2 to 1, and this cost 1 second because 4 minus 3 is 1. Then to print 4, we can move to this 4, and this costs 7 minus 4, 3 seconds. Then we need to print 1, so from 4 we go to this key, and this costs 7 minus 4, 3 seconds. And in total we have 3 plus 3 plus 1, 7 seconds. Another way to do it is we can start, so to print 2 we can press this key, and this costs 0 seconds. Then to print 1 we move to this key, and this costs 3 minus 1, 2 seconds. Then to print 4 we can move from 1 to 4, and this costs 1 second. Then to print 1 we are at 0 at this key 4, so we move from 4 to 1, and this costs 1 second. So in total it's 2 plus 1 plus 1, which is 4 seconds, and this is the minimal time needed to type this string, so we return 4. So how can we solve this problem? What we need to do is suppose or assume that we need to print this number y in the string, and the previous number we printed was x, and we know that the minimal time we spend to print the string up to x is z. Now to calculate y, the minimal time to print y, what we need to do in the keyboard for every y, assume y is here, we need to search for the first x on the left side and the first x on the right side. And that's because if we are at the previous, so we printed x and we are here, and to print y we can move from this x or from this x, and we take the minimum, and we do this for every y. So suppose y at index 0 and x is here, so in this case there is no left, so we calculate this time and we add it to z, and we do the following for this for every y in the keyboard, and we take the minimum. For example, for this string, assume we want to print 4, the previous character or number was 1, so for this 4, the first 1 in the right side is this one, and there is no one in the left side, so assume the time we spent to print 1 is x1. So the time to print this 4 will be x1 plus 1, and assume the time we spent to print up to this one is x2. Now we need to check the other for all 4. So for this 4, the first one in the left is this one, and there is no one on the right side of this 4, so the minimum time is 7 minus 4, 3 plus x2, and so to print 4, the result will be the minimum of these two values. Let's take another example. If we want to print the number 1, the previous value for number 1 is 4, so we know the time to print this 4 already, which is x1, and for this 4 assume it's x2. So we need to check for everyone in the keyboard. So for this one, the first 4 in the left is this one, so the time to go from 4 to 1 will cost 1 second, plus x1, the time we spent up to 4, so it's 1 plus x1, and the first 4 on the right side of this one is this 4, and from this 4 to this one it cost 7 minus 1, 6 plus x2, and that means to print this 4, the minimum will be the minimum of these two value. Now we need to do this for the other one. So for this one, the first 4 on the left side of this one is this one, and to print the one, move from 4 to 1, and this cost x1 plus 4. The first 4 after on the right side of this one is this 4, so from 4 to 1 it will cost 3 plus x2, and so to print this one it will be the minimum of these two, and to print this one we will take the minimum of these two and the minimum of these two, and the final result will be the min of all of these value. Now let's look into the code implementation. So this is the table that we'll use to store the minimal time for every keyboard value. This is a dictionary that will map every value in the keyboard to indexes. So for value 4 or key 4, we have index 0 and 7, and for key 1 we have index 1 and 4. For key 5 we have index 2 and 6. For index 2 we have index 3, and for key 3 we have index 5. Then in this for loop we need to print every number in the string. and find the minimal time to print this number. We start from this index, and that's because for the first number the time is the minimal time always equal to 0. So here we have this condition: if the current number equal to the previous one, we continue. For example, if we want to print 1 and the last or the previous number we printed was 1, the time to print this one is 0, because we are already on key 1. If not, we have to check for every value. For example, if we want to print 4, we want to check for every index 4. That's it. We need to check this 4 and for this 4. For everyone, we need to find the first previous value, which is 1, in the right, and the first previous value, which is 1, in the left side. And to do that, we will use binary search using this method, and we will do upper bound for the previous number and the current index, and that will return an iterator for the first write of the previous number. For example, the first 1 for this 4 is at this index. So what this is, the pointer will return a pointer to this one. So this is the previous number index in the right side, and we calculate this value. This value will be the time, the minimal time to print this one, plus the length of this step, which is 1. So it is TB of previous number index, so this one, plus previous number index manual index, and that is the length of this step. And we do this also for to find the first element in the left side. For example, for this 4, the first one in the left side is this one. So TB of this 4 will be the minimum, the value stored for this one, which is here, plus the length of this step, and we will update the value for this index to the value we calculated, which is the minimum from the left and the right. And at the end, we need to check the minimal time for the last number, which is 1. So we check for the last number, which is s.bag, and we take the minimum of all the TB values. So for example, for this one, we check TB of this and TB of this, and we take the minimum value, and that will be the answer.